Hello and welcome to Beginners Python and Machine Learning, a weekly session on YouTube to introduce beginners to Python and show them some Python coding and also some machine learning principles. My name's Tim Cummings. Today we'll be looking at Plotly in Python, and this will be a bit of a continuation of what we did last week. And hopefully you've seen what we did last week. If not, you could probably still pick up just from where we are. Actually, most of the stuff we're doing is data manipulation, which is good for machine learning type practices. Now, as I go along, you can chat to me. I'll be watching the YouTube chat, and I'll also be monitoring the Learning to Code channel in Slack. There's instructions in YouTube on how to join the Slack channel and also on the meetup page. So if you want to join our Slack channel, the Slack space, just email skypyproject@gmail.com for an invitation. Okay, we're going to provide, we're going to do everything today in Google Colab, and we've provided a notebook for that, so you don't need Python installed on your computer. So if you go to the link below the YouTube video or the link on the meetup page, you'll see this Colab link here, and if you click on that, that will open up the workbook that we're going to be, the notebook that we're going to be using today. What we're going to be looking at today is COVID-19 data. We looked at it about a year ago, and that's when everything was just starting. Things have changed a bit since then. We've had, in the early days, everyone who got COVID still had COVID, so when you're looking at infection rates and spreading rates, then you can just assume that everyone who's got it has still got it. But today, most of the people have actually recovered, so the rules don't apply anymore, so we have to do a little bit more calculations, a little bit more this time to analyze the data. So it's going to be fun. So in this Colab notebook, the first thing you want to do is copy it to your drive, and that way you'll have a copy that you can make changes to. So I'm going to click on that because I'm in a different user now than the one that actually created this notebook. So I'll save it to my drive, and it opens it up in a new tab. And the new name is copy of Meetup 96. All right, there's the link once again. Of course, you already know that because you're here. There's the YouTube link and the Meetup link. And this link here in GitHub is where I store Python versions of these notebooks, so they're not notebook files. They're actually Python scripts. So if you prefer to run this as a Python script rather than as a notebook, then you can go there and grab the Python file. I'll just give a quick introduction for people who don't know how to use Colab. Colab, these notebooks, you have a cell. It's made up of cells. You can see all the cells here. They're these boxes. To execute a cell, you can click in it. You can press the play button here, or you can press Control Enter. If you hover over this, you'll see I'm on Windows, so it's telling me Control Enter is the alternative keystroke to run it. So the very first command we're going to run is we're going to upgrade Plotly on Colab because they provide a pretty old version. So I'm going to press Control Enter there, which is the same as clicking the play button. And this is not actually a Python command. This is a shell command. And I'm accessing the shell by putting the exclamation mark right at the front. I'm using pip, which is the Python installer, the package installer, and to see what packages I've got installed, and then I'm filtering that using shell piping and grep to find out just the Plotly, so I don't get all the packages that are installed. And it tells me that Plotly is version 4.4.1. It's pretty old. Last week we needed 4.5 or later. Probably don't need it this week, but anyway, I like to use the latest if I can. So I can upgrade Plotly by using this pip command, install -- upgrade Plotly, and once again the exclamation mark at the beginning so that it runs the shell command. So you'll have to do this on your computer as well. Click the play button on each of those cells so that it runs, and you can see here it's uninstalling 4.4.1, and it will install a newer one, which is should be about 4.14, yeah, 4.14.3. Okay, these are the third-party libraries we're going to be using in this NumPy, pandas, so they're just good data science libraries to use, and Plotly for data visualization. We'll also be using the standard library math for some of our functions. So we need to import them as the beginning. Now remember, to ask me questions really is aimed at beginners, so feel free to ask any question. I'm assuming a lot of people know this stuff, but if you don't, that's fine, and you ask the question and it'll be benefit all the people who don't know it yet. Okay, so we're going to grab some data from Johns Hopkins, and they've got a GitHub site where they're hosting data, which is all the COVID-19 case data, and they've been hosting this for over a year, and so it's the same data we were using last year. So let's grab that. We can use so we're going to use pandas to read a CSV file from that URL and put it all into a data frame, and then we'll just have a look at what's in that data frame, and that's going to show an error because I didn't execute this one. So you've got to execute each cell as they come. So we'll run this one to import those libraries, and then I can run this one, and it's gone off to GitHub, grabbed the data, and so you can see what it looks like. The head is just showing us the first 5 rows. So it's got a column here for province or state, column for country or region, a bit of a latitude and longitude where they are, and then all the dates, and an extra column for every date. So it's just every day they put in extra data. And so you can see in the first couple of months, that's February, and we're up to just at the end of February, those countries were when they started getting their first COVID cases. And now we're in 2021, so there's a bit of a dot 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 there, and you can see we're up in the thousands of COVID cases. All right, now to use this data, we're going to we're going to start extracting some of the things from this. I've written a web app. Last we did it last year, we wrote a web app that had pull-down menus so you could select a state or a country, and from there, so we needed to populate that list, and this is how we did it. We created a list of states. So DF confirmed, that's my data frame of all the confirmed cases of COVID. I then just use the column province/state, which is this column here, and I just want to find all the states that are in here. There's going to be a lot of them are these NANs, not a numbers. I just want to drop them, so I'm going to use the pandas data frame function dot drop NA, and then I just get the unique values of those, and then I'm going to sort them and print them out. So if I run that, you'll see here there's a list of all the states that this data set is using. So they're not splitting out the American data by state, and a lot of countries they're not doing by state, but they are doing it for Queensland. Just really is what information is available. For America, they've got such detailed information for America, they've actually got another file that they use which gives very detailed location data, even more finer detail than state level. So for this global file, they've just put in the US as a single country. Okay, so let me know how you went with understanding this command here to do the drop NA and the unique. If if at any time you want to go into something in a bit more detail and work out how it works, you feel free to do it yourself. So for example, I can add another code cell in between these two by just clicking on plus code here, or using that Control MB command. I'll create a cell there, and so if I was just to type df confirmed province / state, that'll tell me what I would get, and I get this structure here, and I go, well, I don't actually know what that is. So I can put it in a type function, and it'll tell me what type it is. So it's a pandas series. So df confirmed province state returns that column of the data frame as a pandas series. Now, once I know it's a series, I know what functions I can apply to it. So I know I can apply the .dropNA function to that. So if I do drop NA on that, I can see that drop NA also returns a series. That's good. And then unique, I can run that because that's a series function. I can daisy chain these along here because each one's returning a series. And unique actually returns an array. So I've converted it, by calling unique, I've converted it from a series to an array, and I've weeded out any values that are not unique. In this, there are no duplicates, but that's okay. So now I've got it as a unique, as an array. Then I can run the sort function on that, because that's one of the functions, that's one of the methods that NumPy arrays have. And so you can see the type of AR state was a NumPy array. So running sort sorts the array in place, and it doesn't actually return anything. So AR state is still an array from where that was run, and then I've printed out the array. Okay, so I've given you a challenge here. Try to do a similar thing with countries. And so we want a list of countries in alphabetical order with no repeats. So I've left a blank cell here in which you can do this. So feel free to stop the video if you want, and work on this, and then press play and maybe at a faster speed so you can catch up to me. And I'll go through the solution now. So I'm really just going to do exactly the same as I did for the state. So let's see. Yeah, so I just want to take my data frame. I'm going to select my country, and I've got my keyboard set wrong here, which I should. And what's the name? Country/region. Okay, and then I want to drop any not a numbers from that. I can take the unique of that, and I can store all this into an array, and then I can sort that array. And see, AR.sort doesn't return anything. So when you run a Jupyter Notebook cell, the last item, if it returns something, then Jupyter Notebooks will display that. If you're doing this in a Python script, you have to actually do a print. So I've done prints up there just like I was doing a Python script, but I don't actually have to do that in a notebook. I can just do AR, and it gives me the array. So they're all the countries, and they're all sorted in alphabetical order. And so here I've provided the solution. We We didn't need to do the drop NA because there are none, so there's no harm if we left it in, so that's fine. And it prints it out, so the printout should be pretty similar. It's just a little bit different how it displays things. See, that says array at the beginning, and this one just prints out like a list. Alright, so now we're going to use filtering in data frames. And the way filtering works is you put in your condition. So we want a condition like this, which is saying that we're going to match the value of the country region to a string, which in this case is going to be Australia. And then we want to return the full data frame with that data. And so as you can see, now when we print it out, we get all 8 rows. So there's 8 rows, which are all the states in Australia, and they're all for this country and region. And you can see our data along here. And you can see where New South Wales and Victoria were the first ones to get COVID cases, then Queensland. And this is the number of cases. And you can see it just keeps growing and growing. So some of this early data where it goes down, that'll just be them correcting the data. Okay, so how does this filter work? What I'm going to do is see what this filter actually gives us. So that's the filter part there, and if I just run that, that gives me this series of trues and falses. So it's false, 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 false. Then you'll see when you get up to row 8, 8 to 15, there'll be trues, and then everything after that will be a false. So you put that array of trues and falses inside the square brackets of df confirmed, and that'll just return the rows where there's a true, and that's where we get that list there. Let's try I can put that so there's the first 15 rows, and we get a true at 11. Oh, and because of course the filter there is Queensland, so it is only for 11 is the one that we'll get. So if we put a country region of Australia, we would have got trues for 8, 9, 10, 11, 12, 13, 14, 15. All right, now you can filter by state and country at the same time. You can produce a bunch of trues and falses for the state, a bunch of trues and falses for the country, and then use this single ampersand. And so this is really something in pandas. It's not a Python thing. They've overloaded that ampersand operator to return another array of trues and falses, which will only be true if you get a true in that one and a true in that one. If either of them are false or both of them are false, then you'll get a false. So this should give us the same row, Queensland, Australia. Yep. So that you need that, for example, if 2 countries had a state with the same name. I don't think there is any in this data. Okay, challenge 2. Define a function which takes 3 arguments, a data frame, a country, and a state, and will return the data frame filtered by country, by state, or by country and state. Okay, so this is straight Python, so it's good for beginners in Python. We want to define a function, so to define a function we use the keyword def. We give the function a name, so we're going to call it df for location. And in the parameter, in the parentheses, we're going to put the 3 arguments that we want. We want to give it df country and state. Okay, so Annie's asking, is it possible to lock the first column the same way you can lock the heading in Excel? Not really. This is just HTML that it gets rendered into. So yeah, you're not getting that ability. They do alternate the colors, so it's a little bit easier to follow the rows. But yeah, that's a bit of a problem. That you can't see what the column name is when you're scrolling to the right. All right, we defined our function and it's giving it 3 arguments, and we want to return a data frame filtered by country, by state, or by country and state. Okay, so obviously country or state are optional arguments, so if they're optional arguments we have to provide a default value. So we'll provide a default value of none. So then we can use conditional if statements and see whether we've got a country provided or the state provided. So we say if the country is provided, and if we've got the state as well. So I could say if country is not none and if state is not none, but this is the same, has the same effect. And we want to filter. Okay, so this, if both of those are true, then we want to return the data frame filtered by the country. And let's just copy this because this is going to be easier than typing. So you see how I've enclosed each of these in parentheses. Because otherwise the ampersand there will try to be ampersand on the df and not look at, it takes priority over the equals. So the parentheses fix up the order of operations. So Leo says if it's unique, it can be an index and be locked in that way. So when I'm looking at this is the index here, the 11, but even when I'm scrolling on that, I'm losing my index column. All right, so when I do an if, I like to do an else, so I know exactly what's going to happen. And so if the state exists, I'm doing that. If the state doesn't exist, I just need to filter by country. Okay. Else, so else here is lined up with the if country, so this means the country doesn't exist. So once again, I've got two states, two conditions, if the state exists or it doesn't. So if the state exists now, but I haven't got a country, then I'm going to want this, but without the country bit. And else, I don't want to do any filtering at all, so I'll just return the data frame. Okay, and let's check it works. And yep, so if I provided the country New Zealand, it provided me the data for New Zealand. So here's a solution. It's another way of doing it. So let me know in the comments which one you think is clearer. So this way, I create my filter which doesn't filter anything. So it's just a bunch of trues, and df.shape 0, that's the number of rows. Shape 0 is the number of rows, shape 1 is the number of columns. So I've got a true for each row, and then I just do filter and filter, filter and this filter if there's a country, and then I keep concatenating the filter with state if there's a state. So this might be a bit easier to understand, the one I've just done, if there's only two things like country and state, but this second solution can be easier to understand if you start deciding to rewrite the function later to add more and more parameters, because each one you add just adds 2 lines, while up here every time you add a new one I've got to add another 2 lines here, another 2 lines here, and then another whole group for that third condition. Alright, well, let's check out solution 2 works. Yep, that gave me the same answer. Alright, so Leo's provided another solution that he likes. So dftest.iloc:10 list of columns, toString. Okay, so that way he can show those columns that he wants, and he's just showing the first 10 records for testing, and that way he can lock the index in place. Oh, maybe he just wants the columns so that he's not losing them as he's scrolling off. Alright, so let's use our function we've created, df for location, and grab all the Australian records. Okay, and we'll store those in a data frame we'll call df confirmed by location. And so there they are. Now we want to sum the data frame along the index axis, so we're iterating over the index. So this is the index 8, 9, 10, 11, 12. So for each one of these columns we're going to sum what it is. So the sum of that column will be 0, the sum of that column will be 0, the sum of that column will be 0, the sum of this column will be 4. Okay, so we'll use the sum command and we'll say we're going to use iterate over the index axis, and so let's have a look at what that looks like in a data frame. So that's converted it to a series, and we can see here the sum for the 22nd of January is 0. For the sum for the 18th of February 2021 is 28,918 in Australia. Okay, we don't want these first 4 rows because it's gone and summed. It's summed all the provinces, it's summed all the countries, so they're, and summed the latitudes and longitudes, so that doesn't really make sense to us. So we'll just slice that off and use series sum, which is just another variable name I've created. And so you can see here 26th of January we get a sum of 4, 18th of February 28918. Okay, looking at this data, you can see these index that we've got for our series sum, which has just come from the column names. They're just strings, so we can't really do much with them. We'd like to convert them to date times, and these numbers here are actually floats. You can see the D type there, the data type is object. We like it to be int 64 because later on we're going to need to be doing some calculations on it. So here's how we can convert it. We can use the pandas to date time function to convert the index into a date time. We could also, if we could put a format in there as well, but it works with just the standard month, day, year that the Americans use. And we'll reassign that, the index, to this new value. We'll then change all the data to use int64 type. And then we'll print out the results and just check what it looks like. So yes, our data type now is in 64. Here, these is what date times should look like. So it goes year, month, day, and it's actually a date time. So you can do date time arithmetic on that index now. We can check some of our data. 26th of January is 3 plus 1, so that's 4. 27th of January is 4 plus 1, which is 5. So the data seems to be working. Okay, challenge 3. Define a function which returns a series of values for a given data frame and country and or state. And the index. So it's really what we've just done in individual cells, and we're just going to put all of this together into a function. All right, so Leo's obviously the guru on data frames at the moment. So he's got df.columns, so that's the column names, and then he's got the values of those column names to a list, then restrict how many columns. Okay, so I think he's using that in this iloc. So when you use iloc, list of columns should be numbers, I'm pretty sure. So if you wanted to use strings there, you should be using loc. Okay. So we'll give our function name series sum for location. 3 parameters, state, and just as before, we'll make the country and state optional. And now we'll just grab what we did before. So we're going to be given the confirmed list, the confirmed data frame, and we want to split it down. So we've got the confirmed data frame, and we want to work out the series sum. So that's, we'll do the filtering. We've already done that into df4 location, so we can use df4 location. And then we'll use those. So in our df, so we filter the df, then we want to sum on the index. Then we want to convert, and we want to slice it. And then we'll fix up the data types. So this is really just a good exercise because you have to understand what each of the lines of code does to work out which ones to copy and paste. You don't have to remember actually all the details of each one. Okay, so we've sliced it. Series sum equals that, and then we can return okay. So let's see if that works. So we're going to call the function series sum for location. We're going to pass in the confirmed data frame, and we're going to filter it on Australia. And yep, that's given us the sum of series for that. So let's have a look at the solution now. So it's a few lines shorter than what I've typed. We've right, yeah. So they've used what I did in the solution here is I used named arguments when I'm calling that, which is a good idea. This time I didn't do it up here, but I could do it. It's the first one, so it's using just a positional argument for there. Then we've taken the sum, but rather than store this into a data frame, we've just daisy chained these functions. So dot sum, we've daisy chained onto there, and that gave us total. Then we've sliced it, so we've daisy chained that onto there. Then we've converted the type, series sum as type, and put that on there. So that's fixed the data type. We couldn't do the same with the index, so that had to be another line. So series.index, assigning it to the converted index, and then return that series. And there's our series. Okay, so this is our next challenge: define a function location name which takes a country and or state and returns a name for that location. So this is nothing to do with data frames. This is just a string function now. So really we're getting into the beginner's Python stuff again. We want to write a function that just returns if a country is specified, Australia. If a state's specified, we want to return that state name. If nothing's specified, we want to return the word everywhere. And if we provided both, then we'll provide the state dash and then the country. And the reason we're going to make this function is because when we're going to plot our graphs later, we want to be able to say what location it's for, and so we'll call this function for when we're plotting our graphs. So we define our function. It's going to take two parameters. They're going to be optional. So we provide our default values, and then we'll use our if structure we did before. So if there's a country and if there's a state, then we want to return the state name followed by a dash followed by country name. Else we just have to return the country, and if there's no country, but there is a state, then we'll return the state. Else return. So I'm just going to put in double quotes here. So I'll return an empty string. All right, now when you've been asked, when you're doing Python programming, you can often functions defined for you, and they give you some sample data of what it's supposed to look like. So that's a really good way of writing tests for it. So and you can use the assert function in Python to do your tests. Normally you'd put these away in a separate function, in a separate file, but for now we'll just put them in the same spot. So let's test our location name function and see if it gives us all the right answers. So we got an error on the third one. If the location name no country or state is specified, then we were supposed to return everywhere, but we're returning an empty string. So yes, we can fix our function now that we see that it wasn't right. And we run it, and all the asserts are true, so everything's good. Okay, so this is one way of doing it. And here's another way in solution 4. So once again, we haven't needed nested if statements when we're doing solution 4. We create a list, and then we just append items into that list, depending on which ones are specified. And then we take as many as there are and return them with a dash between them if there's more than one. If there's only one, then it'll get returned, but it doesn't have the dash in between it. And if there's none, then we'll have this if statement says if there's none in there, then just return the word everywhere. So let's test that. And that worked as well. All right, so our next challenge in, so there's a fair bit of data manipulation we need to do with this data. One of the things in the early days of COVID hitting, when there was only a few cases, it was very erratic. It was based on how many people were coming into the country. The data wasn't even that good. And when you're doing exponential curves and logarithmic curves of exponential, you want to start a little way in so that you get smoother data and it's not affected by just those random things that can happen with very small data sets. So last year we were looking at confirmed cases, and we filtered them so that we only started looking at them when there was 100 or more confirmed cases. This year we're going to be looking at active cases rather than confirmed. So confirmed, once a person's confirmed COVID, they're confirmed from then to eternity, but in reality they actually get better and recover or die from COVID, so they're no longer in the active potentially contagious group. So this year we're going to be looking at how to just look at active cases rather than confirmed cases. So we're going to do a filter. We've got our series sum for a location for Australia, and let's have a look at the filter that we get. So here's your filter. It goes false, 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 and eventually it goes to true. And we can apply that filter just on the index, and so we can see that the first date that we exceeded 100 cases, so this is confirmed cases, was on the 10th of March, and then 11th of March, and it's just stayed above 100 from then on, all the way up until today. Okay, so what are we doing? We've got the series, we've filtered it. Okay, that's what we did it on a series, but we want to do it on a data frame. So we'll create a data frame from our series. So we just provide in the series, and we give it a column name of confirmed, and we'll store that in our data frame. We'll call dfSum. So you can see it looks just like our series, but it's now got a column heading. And we want to calculate the active cases. So there is data at Johns Hopkins which looks at how many have recovered and how many deaths there've been from COVID, but that data is not that great. The deaths is probably quite accurate, but the recovered, they're not really following up with people that quickly. So it's quite erratic data. You have big shifts in the numbers when they finally put in their reports for how many people have recovered when they do a blitz on that data. So I found it better to just assume that after 28 days everyone either recovers or dies, And so to calculate the active, we just need to look at how many there were 28 days ago and subtract it from the current number, and that'll tell us how many active cases there currently are. So to do that, I'm creating a new column called confirmed lag, and that's going to lag by 28 days behind. So I'll use this shift function in the data frame to shift it 28 days back, and any because there then won't be a proper alignment, any new cells that we create in the data frame, we're just going to fill them with zeros. Let's have a look at what the data frame looks like when we've done that. So you can see you've now got two columns, confirmed and confirmed lag, and this number here is the 28918 is on the 18th of February, and this number here 28755 is the number 28 days before the 18th of February. So that's easy. Now we can just calculate active is the difference between those two columns. And so it's add a third column there for active, and you see 4 were active at the start, and currently we're looking at 163, 160. So you can see why we can't use the confirmed figures, because there's nowhere near 28,000 people with COVID at the moment. There's only, say, 163 people on the 18th of February. So when we're calculating how contagious it is and what the doubling rate is, we need to base it on how many have currently got it to work out how quickly that's doubling. Okay, so challenge 5, find the date the number of active cases exceeded 100 and what the count was on that day. Okay, so we did the filter before, so we'll just use the same filter. And I really need to fix this keyboard. No. Active. Okay, so the filter is just greater than or equal to 100, and that'll give us all our falses and trues, and then we're going to apply that to the df sum. So that'll, and we can see here that find the date and the number of active cases exceeded 100. So that was the 3rd of March. We exceeded 100. So let's just check that data. We'll filter from a little bit lower. Yep, the 10th of March it was 92. So yes, the 11th of March was the first day our active number was above 100. Okay, so in the solution, we applied that filter to the index, and then we were able to take the first value of the index of, so using square bracket 0 takes the first value and store that into our variable we've just called index start, and the number at the start of actuals, the actual number at the start is we've looked up our data frame at that index value in the column active. I probably meant that to be active, not actual. But and so here we were just able to look at the numbers and see in the printout, but this way we actually worked it out programmatically and storing the values in variables, so that's a bit more useful to us. And we got the same answer. 11th of March we had 113. Okay, so challenge 6, create a data frame which starts when the current when active is greater than or equal to 100. So that's what we did here. That's one way of doing it, but it's not actually doesn't answer the question exactly right. So let's have a look at the solution. So in the solution here we've got several ways we could have done this. we could use the filter just as we've done. And let's print out the results so we can see it. So the first way, df_sum active greater than or equal to 100, and that looks pretty good. It starts from there and it goes on, and we get 349 rows of data, which is actually correct. The second solution we've got here uses the lock function. So when you're using lock, you're not putting a filter in, you're putting in a slice, and your slices is using the values of your index and column names. So we're just doing, we want all columns, so we can just put in the index, and we're going to start from the index start and just keep going to the end. And that works here. That's this one, df_sum.lock index start, and that goes right up to the end, and once again we got 349 rows. Okay. Another solution is to use ilock. When you're using ilock, you have to use numbers rather than index values or column names. And so to get the index value, we've done some code up here. We've taken df_sum, we've looked at the index, and then we've found out what the location, which is a row number, is of index start. And then we can use that row number in ilock. So I'm just providing all the different solutions here, and you can look at which ones you like the best and which ones you can use. Okay. So the other one, another one we've got here is we do a filter, so we reverse the filter. This was greater than or equal to 100. This one's less than 100. And then we sum that, and when you do a sum on booleans, true is considered the value 1 and false is considered the value 0. So summing those will tell you how many trues you get, which is how many rows are less than 100, and then our row, we can use that row number from here. Once again, we get 349 rows. So that's all fantastic, but and that worked really well with confirmed cases, but it doesn't work with active, because active in the future might go less than 100, and once it does that, then these are not going to work anymore, because the filters are going to get rid of the early records, but they'll also get rid of the late records, and so then we're going to lose data. So the only ones that you can use here, you have to find your index start, which we did, and so you can use that one, or you can use the ilock with the irow colon. So I just left that as an exercise for you. Start at 200 and see why you're going to get different numbers for each of those cases if you use 200, because we're now less than 200 again. Okay, challenge 7. Write a function which takes the data frame of confirmed cases, country and state, and returns a data frame of active cases. Okay, so we define our function, df active for location, so what we might do here, rather than provide the country and state every time, we'll use nested functions. So we'll assume that what it gets passed to us is the df for location, and we're going to just return the df active for that filtered list. So let's call it for filtered df. So series sum equals series sum series sum for location, but we're not providing the location anymore, we're just providing the filtered list, and that will work because as far as it knows, it's just going to return everything. it just doesn't know what the country and state's going to be. Okay, we need to convert that to a data frame. We'll give it the column. So I could have just copied and pasted this from before. Then we're going to add the confirmed lag in there using the shift function. And we're going to shift by 28 days and fill the rest with so any not a numbers because of the early data that we don't have. We're trying to bring up earlier data than we really have. We're just going to put zeros in there, which makes sense because it would have been 0 before our first cases, which were at 0 then. And we'll create an active column, which is A's are a problem. So A, which is going to be a difference between confirmed lag and confirmed. Okay. And we'll return that data frame. Okay. So then when we want to call it, we'll use nested functions. And in there we can pass in, we can call the other function, which is already calls the location. And so that's the one we provide confirmed and country equals, and we'll just use Australia. So that function worked. So you can see how we've nested the functions. This is something you see a lot in Lisp as a language, which has had lots of nested functions. And so you spend your life counting parentheses to see if how many times you've nested something. So think which you feel is clearer. In the solution here, we've repeated the parameters here, and we pass them through to series sum for location. So if country is provided, we pass it through to country here. If state's provided, we pass it through to here. I think this way in the solution is really clear, but it does mean that if I wanted to change the filter, add another parameter in there, like city or something like that, then I would have to go through all of my functions and change them. But if I design them this way to use nested functions, I only have to change the very first one, which does the filtering, to take more parameters, and then all the others will just get them through the nesting. Anyway, think which you like the best. Let's have a look at US data in the solution. All right, so there's currently, they've had 28 million cases. 28 days ago, there was only 25 million cases. So that's about 2.9 million currently active cases in the United States. Okay, Leo's providing some stuff. I think he's still working on how to lock the index column. He needs to comment his code more so he can see what he's trying to do. Okay, write a function to plot these numbers after starting count reached. So the default starting count, we're going to count from 100, and the advance is plot the count on a logarithmic scale. Okay, so we're going to do some plotting here. So let's say plot for, I'm going to do filtered again. But I have to provide the num start. And we'll give it a default value, so it doesn't have to be provided every time. Okay, so remember last time we looked at Plotly Express. So it's quite good at plotting out data from data frames. So we have to say what the data frame is going to be and which column is going to contain the data. So X is going to be the index, so we don't have to specify that because it's indexed by default. And the active column is going to be the data. Okay, so let's call our function using df4 location, and we'll do US. Df confirmed country equals US. Value error. Value Y is not the name of a column in DataFrame. Yes. df for location. Oh yeah, what was the name of our function? df active for location. I want that in here. So I'm doing the filter here, and in here I'm doing df active for filtered df. And there we go. There's the so we're doing US. So the US values, you can see it's got up to 827,000 here, 1.7 million, back down to 1.1 million, and then since November it's just been shooting up, getting up to 6 million, but some things have happened. Biden's taken office, they've been locking down, they've got vaccinations happening, and they're back down to 2.9 million active cases. Okay, so Leo's put some comments in here. Print the list of the columns. All right, I would never use list as a variable name because then you can't actually make lists or convert things to lists because it overrides the built-in function name. Get the end of it. So that's list is that's going to take everything from the start to before the last 5 rows. So you know what you're doing there is getting rid of the last 5 rows, and so you're looking at the first 10 rows in the data frame as which is your index, and printing everything except your last 5 rows of your list. I think you probably want to put -5 : if that's what you're trying to do, is use the last 5 rows. Okay, so Plotly Express, really good for quick plotting of data frame, and there's the data out. So let's have a look at, we're going to use Plotly graph objects. So that's GO that we imported them as, while Plotly Express we imported as PX. And what have we done here? We're passing through country and state to call the filtering. We've then filtered active greater than or equal to numstart, and then found the index. We put, I think we had oh yeah, so we had to filter them. I didn't filter on numstart, so I haven't used numstart in mine, so my solution is not actually correct. What I'll do, I should share this for you, so if you want to catch what I'm typing, I will share this. And I will paste that in YouTube chat and in Slack. Okay, so there's the bit that I missed out when I did the solution, which was the filtering on numstart greater than 0. One of the advantages of passing the country and state through to my plot routine is that I can actually label my plot with by calling this location name function we wrote earlier. So it says active cases for United Kingdom starting from 100. So you can see the United Kingdom's got all the way up to 1.3 million, but they're back down to 458,000 cases. So they're doing quite well. I've put it as a linear graph there. We could do that as log if you want to see. It looks quite different here. It really compacts this the top numbers in the curve when you use log. So I think in this case linear actually gives us more visualization about what's really happening. Okay. All right, now I'm going to need to do some more manipulation on the data. So I thought I'd just go through some of the beauties of using NumPy arrays versus your standard Python list. So here I've got a list, and I called it LST, not LIST, and that way this is just my standard Python list, and then I've converted it to a NumPy array and stored it in AR. And so the first thing I want to do is try to add the number 5, the value 5, to each value in the list. So I'm not sure how to do that. I thought I'd try it by just doing list plus 5, and I've done the same thing with the NumPy array AR plus 5. And I can see list plus 5 doesn't work. You can't concatenate an int to a list. So what you would have to do is, if you wanted to do that to a list, you could use list comprehension. So we could say I plus 5 for I in list is the way you could do it in Python, but it's quite easy in NumPy to just say plus 5 to achieve the same thing. Similarly, we take our array and we just multiply it all by 3, and that returns a new array with every number in there multiplied by 3. So the way NumPy's done that is they've overridden these Python operators, the asterisk and the plus, to do these things. But you can't actually override a function that way, because if the function that we're using is math.log10, for example, then if we overrode that, we would have to be in the math library to override it. So what they've done, NumPy's provided a bunch of mathematical functions as well that work on the whole array. So here's what we do if we want to find the log to base 10 of every value in the array. We can just use the numpy.log10, and once again, if we try to use math.log10 on the NumPy array, that's not going to work. Only size 1 arrays can be converted to Python scalars. Okay, so that's a little bit of a background on how to do array arithmetic using NumPy. So we've got a formula here that we want to do on the whole array. So we want to calculate the days it takes to double. So last year we did the days for the confirmed cases to double. This year we're going to do the days it takes for the active cases to double. And the formula is the days, the number of days that we're averaging over. And we look at how many active cases there are now versus how many active cases there were then, which is how long we're averaging. So I think I'll just read through the solution here because there's not really a different way to do it. So let's set the days average to 5. Then we want to calculate the active then, and we'll use the shift function again to do that. So we'll do an active lag, which is 5 days ago, which is just taking the active and shifting it by the number of days we're averaging over and filling any gaps with zeros. Then the days to double is this formula here, and it's just days average divided by log to base 2. So days average divided by log to base 2. We can use the standard Python divided by symbol, the slash symbol, because that's been overridden by NumPy to work, but we have to use the numpy.log to base 2 function of this division df sum active over df sum active lag. And I will just hide this line for now, and we'll have a look at what that looks like when we plot the days to double. Okay, so the number of days to double is these low numbers here, but every now and then it shoots off to these really high numbers, minus 1217. So when it's positive, that means it's days to double. When it's negative, it means it's days to halve. So we really want to be halving as quickly as possible. So we want to be negative, but we want to be as close to 0 as possible. So this is where we're doing really well, and this is where we're doing the worst is actually when we're positive with a very small number, because that means it's doubling every couple of days or so. Anyway, these numbers here on the peaks, we're not really interested in because there's not much happening then. So I can put in a clip. I can clip the data. I'll put in a lower limit and an upper limit and see what it looks like. And so that's clipped those peaks, and so this is really where we're more interested in what's happening. So these days here, days to double is 3, is 5, these is 4, 3. So these were dangerous days, and I think we're in Australia now. These are dangerous days because it was we needed to get up to 6 days before we knew our hospitals could cope, and we were at 2 or 3 days. We were just doubling very quickly. But then we got on top of it. It started to take longer and longer to double, and eventually it started halving over. We went negative, but halving over a lot of days, and then that even got better and better and better. And so this is the best part of the data just here. So as easy it is to visualize a day's double as our vertical axis, it's not really that useful, because the worst is here, the next worst is here, the next worst is here, and finally the best, the worst is here, slightly better is there, slightly better is than that is here, and then the best is just here. So it's all over the place. But what we can do is if we take the inverse of that, then it actually we get a linear, it's continually goes from worse to better on the scale of the axis. So let's have a look at that. I'll get rid of the clip by recalculating this, and then we'll do 1 over our days to double and store that in a column called days double inverse. And in that, when we plot that, higher is worse. So you can see this is the data in the early days. We don't really worry about that. But so really March is when things started to happen, and it was just getting worse and worse, and we started to lock down, and then things got better. So as we go further and further down, that means things are getting better. But then we started to have a little bit of a problem in Victoria. Anything below 0 is still good because it's the numbers are going down, just not quite as fast. But once you go positive, that means the numbers are going up. And so about here, we started to get problems in Victoria, and the numbers shooting up and down until here, then they started going down again. All right. So challenge 10, create a function taking the country and state, the minimum active cases to start, number of days to average over, and plot days to double inverse. Okay, I think I'll just work through the existing functions that are here because they're not really anything new. We're going to create one function here which does a data frame to do all those calculations so that we can call that from different plotting functions, and then we'll create a plotting function for the one that we want now. So all of these lines you've seen before. If you want to do the exercise, try copying them from above and creating the function for yourself. I've got the plot, I've got the clip in there. I think we should probably take that out. And because we're calculating, oh, I see what I've done. I've done the clip after I've calculated the inverse of doubling days, because I don't want the clip to affect that column, but I do want it to affect doubling days. So once I've created this function here, I can use either of those columns and they give me good data to view. And then this function here, plot doubling, it calls the first function to get the data, and it just plots that inverse of doubling days. So let's have a look at what that looks like. Active cases for Australia, so I've got a nice title in there, and we've averaged over 15 days, so it's smoothed everything out a bit more. See, we're getting better, we're getting worse, getting better, and we've had a little bit of a spike here, but not too bad. All right, another thing you'd like to do in Plotly is sometimes superimpose two traces. So this one here, figure 1, that's really this figure here, was the doubling for the location in Australia. We can also then get the data for the UK, and we can add that into figure 1 using this add trace function of Plotly. So we use the graph object scatter to add that data in. We update the title to say we're now comparing two countries, and figure 1 we return that. Once again, this is the last line in a Jupyter Notebook cell, so that's the one that will produce the result. If you're doing this in a script, you'd have to say figure1.show so that it shows it. And here we go, we've got the two countries. So this is comparing England, the United Kingdom, to Australia. And you see they started getting cases before we did, but we got cases and we started doubling very, very quickly. Remember, we're starting from 100, I think. And then from March the 8th to the 0, so this is when cases started going down, to April the 18th. So that's a month and 10 days it took us to turn around to actually slowing down the number of people that we got. While the UK, they went from February the 29th to May the 7th. So that's March, April, and the beginning of May. So 2 months and 7 days. So they're not in positive territory for much longer than us, but because of that, it really made things worse for them. We managed to really lock down hard and reduce our numbers significantly by this really low rate. So here we're halving very quickly the number of cases and still reducing up until here, June the 19th, while the UK was slowly reducing, but they were reducing, and they reduced for a long time. But here we see the benefit. I think this is due to seasons. So here, this is our winter and their summer. So they're in quite good shape during summer, and we're having all sorts of problems in winter. But then we locked down, and finally in August the 20th, we managed to stop the increase in numbers, and down here we were reducing and kept them all very low. So the UK, the doubling didn't get very high, which is really bad, but it just went on for such a long time, July 29 to November 25th. Once again, that just gave them that big spike. It halved for a bit, but it came back, and so that didn't reduce it much. So when they started increasing again, they were increasing off a bigger base. Anyway, I find that interesting. So the advanced solution to challenge 10, what was that? What was the question? Plot at the same time as count using plotly subplots. Oh, okay, so how to use subplots. So to use subplots, rather than fig equals our go.figure, we go and create these subplots. So we create 3 rows and 1 column, so we've got 3 subplots we're creating. In the first one, we want the graph that goes in there to span 2 of them. The second one, we don't want anything showing in there because the first one's actually spanning into that one. And the third one, we'll just use the default. We just want a graph to show in there. And we'll give it our cases. And let's have a look at what it looks like so that we can see what the rest of this code does. So this one plot command creates 2 subplots. This one's twice as big as this one because it's spanning 2 rows in our grid. And it's showing active cases on a logarithmic scale, and this one's the inverse days to double. So you can see we've updated the layout. So this is the total. This is the title on the whole graph, and then each of these ones up here in subplot titles is the title on each individual graph. And then we've added another one here, which is our line to show what it would look like if we doubled every 6 days. And so we've just done some calculations there, which I won't go into too much detail with. Challenge 11, add lines on the log chart for doubling every 2, 3, 4, or 5 days. So we've really taken these lines of code here and put them in a loop so that we could do it for several days. And you can see the loop here. So these plotly charts are really quite powerful. It's all done in JavaScript and HTML, but you can, while you're looking at it, you can turn off particular ones. So I can turn off every 2 days, and so that's rescaled the whole thing, made every 3 days go up to the top. You can see how the scale, every time I turn one off, it changes the scale here. And this is active cases in the United Kingdom on a logarithmic scale. Okay, are there any more questions on that? If you'd like, I can go into more detail on these more advanced plots, but really they're just there to show you what can be done, and you just have to understand what the ways to do it. So adding extra traces, using subplots, they're all useful features. I've got an electrical storm outside, so I might finish off here. Thanks for watching. Next week is going to be an absolute beginner session on the 2nd of March. I'll be taking that. So it'll just be getting started in Python. If anyone would like to join me for that. I hope you've enjoyed what you've seen tonight. Let me know if you want me to show you how to put this all together into a Dash web app, which is Dash and Plotly are closely related, so that and a Dash web app is you can create a dashboard in Dash that shows this particular data.